Thank you, Giorgio, and also a warm welcome also from my side. It's exciting to be here and to start with the presentation of the first destination. Maybe you can go back with the slide just for the introduction. So destination 1, network management, planning and control and mobility management in a multimodal environment and digital enablers, has the objective to achieve the single European rail area by researching, developing and delivering a flexible, efficient, resilient and high capacity European network. It's also about the implementation of a railway digital enabler and digital twin environment where all the digital elements of the system can play together in a coherent and interoperable way. The action to be funded under this destination should address 2 work streams and should target the following impacts. Improved strategic and tactical planning of the rail network, for example, increased number of possible trains on a given infrastructure, improved processes and methods, reduced answering time for cross-border train pass requests, and improved timetable robustness. Next impact should be to develop resilience for a connected real-time network with improved prediction quality and prediction performance for the traffic management system, and shorter ATO journey profile provision. And lastly, also to integrate rail traffic within door-to-door mobility with more precise demand forecast and improved demand-supply matching. Now let's look at the expected outcomes. And if you can go to the next slide, please. So workstream 1 should deliver by 2025 the innovative solutions that will be demonstrated with tactical and short-term timetable planning, including cross borders with improved models and functions, use of decision support to support integrated capacity planning of rail network and operations for yards, stations, and terminals, and should achieve a TRL level of 6 to 7. Then the human-machine interface for the traffic management system with decision support modules based on user experience design and human-in-the-loop awareness with a TRL level between 6 and 8. And lastly, demand-driven predictions to improve operations and service offers, considering information about the events across modes. Effects of cross-regional multimodal travels in combination with demand forecast and disruption handling on improvement of daily operations, benefit of customers in terms of accessibility and attractiveness with a TRL level between 7 and 8. Next. So the action should also do the preparatory works for the future set of demonstrations, so in a later stage. And this would include functional system for strategic, tactical, and short-term planning using integrated feedback loops from operations, using ATO journey profiles for timetabling, TMS at regional area with decision support and interaction between actors, TMS at global area with decision support and automation, and overall a real-time traffic plan with feedback loops from operation to planning, improved long-term demand-driven predictions, use of digital twins for visualizations and modeling of movements at train stations, and finally also cross-border travel within Europe and the connection of rural areas. In terms of scope, the action should research, develop, and deliver the following capabilities, just to name a few: European cross-border scheduling with international train path planning, improved capacity location using rolling planning and TTR, decision support for short-term planning, integration of TMS with yard capacity planning and station capacity planning, and so on. So the full list is, of course, available in the call text. Next slide, please. The second work stream is addressing the digital enablers and should deliver by 2025 the following: develop data federation, access and processing services through standardized interfaces, develop a common machine-readable domain ontology, and ensure a powerful, secure, and reliable data and communication infrastructure. Next. This destination should also do the preparatory works for the future set of demonstrations, such as for modular build-up of digital twin within the development environment, use of artificial intelligence to collect and analyze data patterns and supports decision-making process, and the use of real-time algorithms with digital twins. The enablers, capabilities that are foreseen to be developed for this are the connectors for federated data spaces, common domain ontology, and digital twin support, development, and execution environment. So this is all from my side. Thank you for the attention, and enjoy the day.
Thank you. Good morning. Good morning, everyone. I hope you can hear me loud and clear. I will indeed present this morning the content of Destination 2, which corresponds to the activities included in Flagship number 2 on digital and automated up to autonomous train operations. So what do we want to achieve with this Destination 2 for the overall program? It's very, very simple and very clear. We want to increase capacity without increasing the cost of capacity. How do we want to do that? We want to digitalize and automate as much as possible the railway system and the railway operations. We have key impacts that are developed in the call. If you've had already a look, you should have seen that already. We want to achieve very, very specific impacts with this destination and with this flagship overall at the level of the program. Those impacts are lowering the cost, as I already mentioned, decrease the travel time, increase the capacity, increasing the punctuality, increasing the operational reliability of the overall system, improve the recovery time in case of disruption, and this is very, very much linked to what my colleague Goras presented just before the coffee break in Destination 1. We want to reduce energy consumption, and we want to improve overall the flexibility of the operations. To do so, we expect the development of a number of technical enablers that will be used for building this next generation of ATC, so automatic train control, technologies throughout the program, throughout the Europe's Rail program. We expect that those technical enablers will then be demonstrated in a set of specific operational scenarios. Two key points before I go to the core of the presentation and presenting what we really expect from this first call. Regarding the segments, we expect that the technologies will have an impact on light urban railway, on high-speed lines, on freight operation, and on regional lines. Second key point, and it is very well developed in the call, and I strongly suggest whoever is intending to prepare a proposal to really have a close look. We really want and expect that the work to be done in this destination will be using as a basis the results coming from the different shift-to-rail projects that are either closed or still ongoing. So we've detailed this very well in the call, and it is very, very, very much important to take this into consideration when preparing your proposal. If you can go to the next slide, please. Without further ado, entering into the core of what we want to see at the end of this first call. We want that by 2025, the following are delivered, and it's quite ambitious. Stay with me. We want to see a set of technical and functional enablers, such as ATO, grade of automation 3 and 4, over ETCS, to be developed and demonstrated at a higher at a high TRL level, so TRL 7 or higher. And to go with this ATO grade of automation 3 and 4, we also expect the development of hybrid level 3 of moving block, of train integrity monitoring system, TIMS, at TRL 6, connectivity solutions at TRL 7, perception solution for automation, we need to know what is on the line at TRL 6, train positioning at TRL 6, and automated functions and digital register at digital 6. So really this set of technical enablers really constitute the core of what we want to develop and demonstrate in this goal. Second, we also want to see demonstration of remote driving and command in depot and yards, including again the perception system, quite important. At TRL 6, we want to see a first demonstrator of the next generation of automatic train control for both the module on board and the trackside at the proof of concept stage. And this is very much linked to the work that is going to be done in the system pillar. Giorgio has developed this quite well in his introduction. I will come back to that at the end of my presentation. In addition to this, we also want to see quite a number of technologies at the level of either proof of concept or validation in lab and or ideally also on the field for the following: virtual coupling, self-driving wagons, autonomous path allocation, very much linked to destination number 1, and this is very well detailed in the call. Validation and certification aspects, obviously, we want to be able to make it to the market, so we need to take this into consideration. Demonstrating the functional open coupling at for the required subsystem, at a TRL 7, and demonstrate a modular hardware platform using the architectural software design patterns and methods, and this at TRL 7 again. So this is what we expect by 2020 to be delivered by 2025. If you go to the, thank you, for the next slide. We do not only want to see results in 2025, we also want to make sure that we are preparing the activities for the post-2025, for the post of this first call. And there we have detailed, and it's also included in the call, 3 main aspects that we need to be taken into consideration so that we can further take those technical solutions after 2025 and continue the work expected in the program. So this includes the integration of those technical enablers and functions and enhance their different functionalities, the different performance capabilities, so that we can take this step further after 2025. We'd like to also look into ATO GOA 34 for depot and yards and specific lines without train protection, which is a reality of the current market. And start preparing the next generation of automatic train control with generic solutions and applications tailored for regional low-density traffic lines, and also highly automated urban light rail operations. So it's important to take those extra 3, let's say, aspects to take into consideration when preparing your proposal. Last but not least, I'd like to mention 3 key, 3 last important elements that are included in the call, and I think it's important to mention them now. The call describes quite a number of interaction and collaboration expected between destination 2 and other destinations in the call. I will not enter into the detail now, but it has to be taken into consideration because there's a lot of input and output expected. And please be very, very careful about that because a lot of the program relies on this collaboration. Second thing, the interaction with the system pillar is specifically important for destination 2. So it's a matter of making sure you are making room for this collaboration to happen once the project will be launched, if you are successful. And finally, taking into consideration projects or programs that are ongoing outside of the Europe's Rail program. So this includes, for instance, what our colleagues in Prague in EU SPA, the EU agency for the space program, are financing for train positioning. So we need to make sure that we are always aligned with what is coming out of the program, and as well what the European Commission is financing on 5G, for instance, for the connectivity part of the Destination 2 program. This is it for me. Thank you very much for your attention, and I will answer your questions later on.
Thank you very much, Leah. So indeed, I saw also some questions. We can also reply later on, no problem. I pass the floor to my colleague Sébastien, which will present us Destination 3.
Okay. Thank you very much, Giorgio, to give me the opportunity to present Destination number 3. And good morning, everyone. So what are the overall objectives of this destination? So basically, this is to deliver a common European asset management framework, so composed of the green, digital, and safe set of solutions for the railway sector. It will focus on 3 areas. The first one on a cost-effective asset management system, addressing short, mid, and long-term intervention planning, supported by digital technologies and data analytics. The second aspect, this is the advanced and high-tech automated execution of construction and intervention, supported by robotics and wearables that will improve the health condition of workers and the quality of the results. Finally, the third last point, is the production of resilient and eco-friendly assets. So as highlighted by Leah, this destination is also largely built up from the results of the Shift to Rail program, especially the program number 3 on infrastructure, but also in some extent of IP, such as IP2 and CCA. So the proposal should then deliver solutions that can be demonstrated by a system approach and supported by several use cases that will cover the 7 demonstrators that I will detail just after. So Joshua, if you can go to the next slide. So the first demonstrators is indeed the one on asset management and TMS. So the overall idea is to show the integration between the intelligent asset management system and the traffic management system to enable the share of data and optimize decision using common metrics. So how to materialize this demonstrator? This is with the development of a scalable information platform to integrate and exchange information across the supply chain and the TMS. So among others, it will secure standardized interfaces, methods, and processes for different data exchange. The expected impact of this demonstrator, this is basically to have a qualitative and prompt integration of information, so including the reduction of time of transfer of the asset condition status to the TMS, and this with a 50% of improvement in specific use case. The second demonstrator is about the asset management and the rolling stock, and he has for overall objective to present monitoring of rolling stock solution leading to decision and planning of intervention based on automatic inspection. So it should include onboard and wayside technologies as per these demonstrators. The fourth one, I will skip the third one for the moment, but the fourth one is somehow the twin of this second demonstrator, but for the infrastructure assets, okay? And the overall idea is something similar with the, say, the enabler of having prescriptive intervention, minimizing dangerous situation, and service disruption during operation, okay? The third one, the long-term asset management, will develop LCC models for infrastructure and rolling stock. So these 3 demos are somehow linked in the implementation. Why? Because somehow what we're expecting to have developed to reach this demo, this is to have an improved asset diagnostic and inspection system, as well as a main automated monitoring and inspection solution. And we're going to use some technical enablers to do that. So artificial intelligence and machine learning solution and data fusion algorithms, as well as secure standardized interface for different data exchange. The expected impact for these 3 demonstrators are the following. So first, the reduction of maintenance cost, targeting 10% in specific use case, and or 25% of reduction of in-service failure. More specific for the second demo, this is the increase of rolling stock availability targeting 10% in specific use case. And for the demo 3, the improvement of the accuracy of long-term asset management by 20%. Next slide, please. So the asset management and digital twins. So the focus should be on design, maintenance, upgrade, and renewal intervention driven by digital twins for the optimization of processes, maintenance, planning, and involved logistics. So the digital twins demonstrator should be integrated with BIM, GIS tools, and virtual and augmented reality to enable visualization of the asset health status. So the expected impact is to have a number of assets managed and monitored by digital twins with an increase of 20%. The demo number 6 on design and manufacturing. So the objective is to have advanced and holistic design and certification of assets based on new ethical by design materials with advanced ATC characteristic and advanced embedded sensor for self-diagnostic materials. So it should include the use of additive manufacturing techniques, self-healing techniques, and materials. So the expected impact for repair at the extension of remaining life by 20% and 20% time reduction from design to manufacturing, as well as cost reduction. Finally, the last demonstrator is about robotics and interventions. So we are aiming to have development of remotely controlled unmanned for construction, maintenance, and renewal operation based on two aspects, either the non-invasive or collaborative unmanned robotic actuators, wearables, and vehicles based on AI and ML, and as well additive manufacturing techniques to repair assets. The expected impact: increased accuracy and reproducibility of inspections of 25% with respect to conventional intervention, and the cost reduction of the intervention by at least 10%. So this is the 7 demonstrators I wanted to present. These demonstrators for innovative solutions should have several operational differences to be covered. It includes climate aspect, so it has to take into account the different and the variety of climate in Europe. The line type, so it should address high speed, conventional, regional, suburban, and freight lines. Traffic type, freight, passenger, mixed lines. Asset type, as already described, infrastructure and rolling stock. And finally, the planning level. So it should address strategic asset management plan level, asset management plan level, and the implementation of the asset management plan level. So each of these high-level demonstrators should be further detailed and filled with specific use case that will illustrate the impact of the technologies in concrete solutions. So the choice of these use cases should be based on the sound business cases. And additionally, if there is an opportunity to achieve a more integrated demonstrator, we need to pursue this possibility and to present them. As described in the call, there will be also some elements to be provided to 2 other destinations. So one on the development of CBM methodology for destination 5, and the scalable intervention platform should be done in a tight collaboration with destination 1. So this is it for the presentation of destination number 3. And as you have seen below, there's also some preparatory work that will be done for the next periods, mainly aiming to prepare higher TRL solution for the demos I described. Thank you very much.
Thank you, Sébastien. So this is the presentation of the destination 3. You can see all the content that Sébastien described, of course, in the slide. I will move on and give the floor to Javier for the presentation of destination 4.
Thank you very much, Giorgio. I hope you can also hear me clear and loud. So I will just thank you very much for the confirmation. So I will be presenting today the flagship area, the destination 4, which has the goal of providing new innovative products and services based on leading-edge technologies to minimize the overall energy consumption, environmental impact of the railway system, in order to make this transportation mode healthier, more attractive, and to provide resiliency against climate change at a reduced, of course, total cost of ownership. In order to achieve these general objectives and building upon the work of Shift to Rail program, as my other colleagues have already clearly mentioned, and not only in Shift to Rail but in other research and innovation programs, this destination should provide solutions oriented towards a more integrated and standardized rail power smart grid, integrating greener energies, cutting peak of energy consumptions, and allowing for a better control and management of the energy systems. Provide, of course, developments oriented towards a better energy management at station level. We could consider even stations as energy hubs, providing more intelligent and integrated control systems and allowing for a larger energy flexibility and resilience of the electrical smart grid in the railway system. Of course, this destination is also looking to be able to provide technologies for a more sustainable and nowadays extreme hazard resilience design of railway infrastructures and rolling stock. And this rolling stock, of course, oriented towards the whole life cycle, reduction of the whole life cycle of the assets, and even supported by digital twin developments, as my colleague Sebastian was mentioning just before me, within Destination 3. Of course, this destination will provide sector tools for the efficient implementation of circular economy solutions in the railway sector in relation to the infrastructure, rolling stock, buildings, any type of assets, and for sharing and communicating this accurate environmental data toward the stakeholders. And as well, a set of guidelines for the design of modular stations according to size and uses. Of course, there will be risks associated within this destination, and they are mostly related to the fact that these relevant technologies for achieving sustainable and green rail system, such as the innovations on hydrogen solutions, batteries, sustainable construction technologies, are primarily developed by other industries and under partnerships other than the Europe's rail. But in that sense, and you will be able to see clearly in the call text, we are of course establishing these synergies with other research and innovation programs, not only considering the rail as such, but also considering this new implementation of technologies that may boost the technology or the TRL levels within the subsystems in the rail. Okay, so in that sense, please have a look at the call text, because in this sense, you will find these links we are establishing with other research and innovation programs. Okay. Of course, this risk may cause difficulties in transferring these innovations directly to railways for reasons such as the cost of the technologies being developed within other programs, incompatibilities of standards, or other technical constraints. But the innovation programs is set to make these links and to make these possibilities feasible. So in that sense, again, have a look at the synergies, and we will be, of course, working with these other programs in this respect. And this is the reason why the selected proposal for this destination, for funding under this destination, will be a project of Europe's rail with significant expected impacts. And that has been already highlighted by Carlo this morning, by Giorgio afterwards, in which we will require an integrated sector systemic approach. Okay, so indeed, in that sense, proposals should set out a credible pathway, including an exploitation plan, to contribute to the expected impacts as described in the master plan that Giorgio was mentioning also before. But now, Giorgio, maybe going to the next slide, the first one, in order to go more into the details of the destination. The project stemming from this destination should deliver by 2025 innovative solutions to be demonstrated by alternative energy solutions for the rolling stock, covering topics like the ones I briefly mentioned before. And they are also specified in the call, such as high performance BMUs, hydrogen hybrid trains for duty inspections in vehicles, for local freight, for passengers, etc. And of course, addressing solutions that will impact the suburban catenary trains with energy storage systems, and of course, being able to adapt automatically the train energy consumption to the service situations, the different scenarios that may be in place. Okay. The second bullet point, of the holistic approach to this energy in rail infrastructure, will have to cover a rail power smart grid in different systems and integrate energy storage solutions, as well as the application of solutions for the production, storage, and refueling of hydrogen for railways, for railway vehicles. As an example, would be one of the topics addressed in this second bullet point. Of course, the solutions within this destination aims to also deliver value through the development of solutions and models for the reduction of noise and vibrations, together with the advanced prediction of the effect of degradation to enhance the resilience of the rail system. The fourth bullet point in the next slide is addressing the solution that should also cover the improvement of the electromechanical components and subsystems for the rolling stock, such as electromechanical brake systems, pantographs, suspensions, optimized motors, gearboxes, as also mentioned before, continuation of the Shift to Rail program activities, and that you will have the chance to see in the context with the related work objectives and outcomes achieved so far. And last but not least, under this destination, we are also covering the attractiveness and healthier and safe and healthy and safer rail system approach, because while improving comfort and accessibility to trains in a safe and healthy manner, we are making the rail the everyday mobility option for the society, as stated in the Europe's rail mission. So that's also going to be covered within this destination. Okay, and just one slide, if we can pass to the next one, to mention that in addition, and as previously commented by my colleagues, the proposal should cover important preparatory work that needs to be launched for the future of a set of demonstrators foreseen in the multi-annual work plan. Okay, and in view of these evolutions of the solutions, meaning, well, integration of these technical enablers for high performances BMUs as continuation of the work in this first call, enhance these standardized and interoperable battery charging interfaces, data protocols to ensure cost efficiency, scalability of hydrogen solutions like refueling stations and energy storage applications, airless train components, evolution and technologies used for the reduction of these externalities, we also mentioned before. And last but not least, the preparation and or simulation of these integrated demonstrations in real environment for modular rolling stock. This is a bit of in a nutshell, what the destination 4 is aiming within the flagship area 4. And we will be happy to answer any questions you may have once we are done with all the descriptions of the destinations. Thank you very much.
Thank you, Javier. So here was the presentation of Destination 4. As you can see, we're already replying live in the chat to the question, but also you can keep us some questions if you want at the end. But I think we have a good flow of exchanges. So I give the floor now to my colleague Manuel, that will present Destination 5.
Good morning, everybody. I'm happy to introduce you to Destination 5, Sustainable Competitive Digital Green Rail Freight Services. As a start, I would like to say that the main objective is to transform rail freight into a more attractive and accessible means of transport for goods in order to support the needed shift to rail from roads as required by the Green Deal. We aim to contribute to this by mainly three things: increasing capacity in a smart way, delivering a better service, and of course, at a very competitive cost. We have two cornerstones to develop this plan. One is the digitalization and automation, which is going to mainly happen through something called digital automatic coupler that we can talk a bit afterwards. And also addressing a very important thing within rail freight, which is the seamless, or I would say the better integration regarding all the stakeholders in the value proposal. So if we go to next slide, we will see that this destination unfolds in two different work streams. One is called full digital freight train operations. In this work stream, we encapsulate all the digitalization. We aim to encapsulate all the digitalization and automation needed and can be delivered with a digital automatic coupler. Just a couple of words on what is a digital automatic coupler. Basically, the aim is to deliver a coupler between wagons that couples and uncouples automatically. It delivers the braking system, and not only the braking system, but also the digital transmission of data. So this is communications, and also very important for freight, the transmission of energy through different wagons. This is a massive leap for the rail freight, which has been living in the dark ages, more or less, or in the caverns, regarding all the possibilities of the digital world and automation, mainly because the coupling today is done through screw couplers, and there's no transmission of any network apart from the braking pipe, but this is done mainly automatically. So this digital automatic coupler is going to enable and pave the way.
Manuel, sorry to interrupt you. We are just upgrading your IT equipment, so that in a moment we can hear you well. Maybe you can also give when you restart, you can give also a little summary of what you have been just discussing. We have enough time for it, because I see in the chat some comments that indeed your sound, your microphone was quite poor. So I think now it should be fine. Try.
Give me 1 second, please.
Yes, now we can hear you. Try to speak.
Yeah, can you hear me now?
Yes, much better.
Okay. Okay, so back to the first slide. Okay, first of all, my apologies. I thought it was going to work well. So these are the things of live presentations. So as I started, I would like to say that this is Destination 5, Sustainable, Competitive, Digital, Green Rail Freight Services. Our main objective is to transform rail freight into a more attractive and accessible means of transport for goods in order to support the need of a shift to rail for good from roads to rail, basically, as it is required by the Green Deal. We aim to contribute to this objective by three things mainly: increasing capacity in a smart way, deliver a better service, and of course, at a very competitive cost, acknowledging that these are the three important things to become much more attractive and to gain the confidence of the market. How do we plan to do so? Mainly by two things: improving the digitalization automation. I would say, moreover, transforming that completely in this area, the rail freight services, and delivering a much better integration of the rail freight, so it can be seen as a seamless service, close to could be a mobility as a service or freight as a service. If we can go after this short introduction to the next slide. Okay, this is Destination 5 unfolds in two different work streams. First work stream mainly deals with the digitalization and automation. And now I need to stop and talk a bit about what is DAC, a digital automatic coupler, which is going to be the cornerstone of this work stream. In Europe, since almost the start of the rail freight operations, it has been done, the coupling and uncoupling of wagons in a manual way. And there is, up even today, no data transmission among wagons, and there is no energy transmission among wagons. In the rest of the world, United States, China, Russia, automatic coupling is something very well introduced since long. And we need in Europe, in order to be more competitive, to step forward, not only for automatic coupling, which is the mechanical part, but we're going to deliver also the digital and the energy and the necessary energy for freight. No? This is going to really transform, and it's a big, big revolution within the rail freight market, as we are going to enable, a lot of functionalities and end user capacities that are going to trigger a massive revolution within the rail freight. On top of this digital automatic coupler is going to help reduce the cost, as it's going to automate a lot of activities that are going to require less effort, and it's going to be done in less amount of time. Therefore, we are going to better use our capacity. So we are going to increase the actual real capacity by significant percentages in order to fulfill this Green Deal, which is going to request a lot of capacity with not so much investment, delivering more capacity for rail freight. The digital automatic coupler, it's something that we build on. It's something we inherit from Shift to Rail IP5. It is a product that will deliver not only the mechanical coupling of wagons, but it will also deliver the braking service, which is the air pipe for braking, and also the communication and the energy necessary for enabling whatever customers would like to have in their freight containers or in the freight clever freight deliveries they may wish to have. Basically, this work stream aims to deliver 3 different demonstrators within this period of time. The first one is that we aim to deliver a large-scale demonstrator showing the full digital train operations based on DAC Type 4. The typing within DAC is how far are you within this coupling and uncoupling. Type 4 means that you are able to transmit data and energy among the freight consists, through the DAC, which is basically the gateway for doing this. Type 5 is the one that is not only able to couple, but also uncouple automatically. So we can switch and unswitch elements in a convoy remotely in an automatic way. So basically, this first demonstrator will show a full digital train up to DAC Type 4 in different regions with several train sets in order to get real feedback within real operation conditions. And the important thing about the DAC is that this is a major change within the network. So we cannot afford having some wagons with DAC, other wagons not with DAC. So this is a major change in the whole freight network. So it is important to deliver a lot of experience before making the migration. So it is important to not only test the thing in a self-contained scenario or self-contained test bench. So the idea is, with this full digital train operation demonstrator, the first one, is to move a set of trains, real trains, through different European countries, and to see how the system behaves and how it adapts to the different realities of different places. So this is a very ambitious objective, and we expect that there is going to be of a very important impact, as it will pave the way for the standardization and implementation of the digital automatic coupler in the whole Europe. A next step is how clever this DAC becomes, and is the next demonstration which happens in parallel. But the expectation is this one is not so. It's going to go to a technology readiness level lower, so the lower maturity level. And the aim is to start testing in real life different added value functionalities that the digital automatic coupler will enable. So basically, it is this demonstrator where we start testing live up to high tier levels, telematic applications for customer requirements, like could be perfectly, for example, checking temperature within a container, or checking the kind of vibration that the container is having, just in case it is moving sensitive goods from one place to another. Check how the situation is, for example, for a safety-related application, like imagine you want to detect fire or whatever. And a very important thing is, for example, this thing of distributed power system for having distributed traction and having locos all through the consist, and it is everything controlled through the communication system by the main locomotive. Finally, it is very important also the electro-pneumatic brake, and this possibility of moving to a much better and clever management of the braking system within the rail freight. We want also to not only make a big revolution within the rolling stock, but this revolution needs to go by the hand of what happens in the ground. Basically, for freight trains, the station is like the yard or the terminal. And it's very important that the automation, it happens also at the same pace and in accordance with what is happening in the train. So in this demonstrator, we are going to build all the capacities and demonstrating capacity regarding our yard automation equipment, wagon identity system, allowing automatic shunting, video gates that will help us checkpoints with visual recognition and artificial intelligence tools for yard automation. Next slide, please. This work stream is also very important. It's the seamless freight. Basically, before I get into details, there are like certain things that we need to improve within the rail freight, and this work stream aims to do so. And they mainly deal with integration. So if we go to the first one, we can talk about cross-border. So a freight lorry takes between 1 minute or 30 seconds to change from one European country to another. It's just another, it's another kilometer within the plan. While for a freight train to move from one country to another can take days because of different things. So in order to be more competitive, we plan to really boost this area of cross-border and make it as competitive as possible, aiming to reach the same competitive levels as the road traffic. This happens through different initiatives. One of them is to really support and further develop the corridors, European railway corridors, and mainly through the train management systems. Having train management systems that talk to each other, and they can easily hand over trains from one region to another, from one country to another. And then with trying to automate as much as possible all the necessary checkpoints for accepting rolling stock from one country to another. And finally, is making all the necessary information to accessing shunting yards, terminals, etc., in a very digital and fast. So basically, it's to better integrate all the stakeholders in this handing over of rolling stock from one place to another. So they are all integrated. They've got all the automation and digitalization necessary for making this happen. And this is like the first demonstrator. They should be addressed in this call. And we need also not only to integrate the handing over of trains, but also we need to integrate the logistic chain. So we need to integrate somehow customers, and we need to integrate somehow the forwarders, and we need to give enough information to the end users, so rail freight is not like a black box, not reliable. We know that we have left something to be transported, but we don't know when and how it's going to be delivered. So the idea is to give transparency and to better integrate with the Internet of Logistics, being able to give all necessary information to the supply chain. So whenever there are disruptions or whenever there are needs for special treatment of a situation, the customer is perfectly aware, they can react fast, and they can also track and better serve the just-in-time production systems. So basically, this is the main aim of this work stream. So it's better integration. And these are the two demonstrators and the TRL level that they are expected to achieve. Next slide, please. Okay, in addition, in this call, out from a demonstrator, we expect important preparatory work, as it is specified in the multi-annual work plan, for delivering train integrity and train length determination. This will come through DAC again. Digital automatic coupler will give a electronic network from head to tail that through that train integrity can be built on, and this train determination necessary for knowing, especially for traffic management, the kind of traffic they're managing. Then ATO, it's a very important part in this digitalization automation, especially within yards, and in any case regarding rail freight. So we expect this preparatory work on this self-propelled wagon concept, automatic and autonomous loading and unloading technologies for last mile distribution. This is very important. You can go very efficiently from A to B, but if you're not able to load and unload things efficiently, then the important thing is that the customer does not get the goods on time and with expected efficiency. So it is important also to better integrate and to be highly multimodal. Fully automatic shunting locomotive movements, they will support the full automation in yards, and further work in seasonal freight corridor and seamless customer freight. And this is in a nutshell what is Destination 5 call objectives for this 2022 call. I am going to be very happy to answer any question in the question and answer part.
Thank you, Manuel. Thank you very much. So in the interest of time, I immediately give the floor to Judith, my colleague Judith, that will present to you Destination 6.
Thank you very much. I hope that you can hear me well. There is no technical issue. Okay, great. So I would like to present to you the last destination of this annual work program. And here, this is focusing on the regional rail services and innovative rail services to revitalize capillary lines. So this is indeed, it's quite an important area when we are talking about sustainability. And then it was also mentioned by Rosalind, the carbon neutral European industry and future. So we have to make the regional lines and the capillary lines more back to the use of the railway network. But of course, considering that we are linking it to a multimodal environment, and then we have to also consider the last mile solutions. Also, I would like to raise what Christian said before, that we love trains, but are we willing to pay for the price and then spending hours in the train? And this is also the objective of this destination or FA, that to lower the system cost while increase the productivity and improve the customer satisfaction. So by this, we can make a more cost-efficient and reliable and productive railway network, while having well-functioning and well-integrated regional railway services. What is covered within this area? You can see already in the multi-annual work program that it's covering various areas like the control, command, and signaling and operations aspects. Then it's also focusing on infrastructure assets, then rolling stock, and the last point is customer services. So in this destination, all these areas are covered with specific areas to focus on. What I would like to raise as a point of attention for this destination, that it was already mentioned in the other destinations as well, but there is a strong need for interaction with the other destinations. So here the focus is on demonstrations, and then some of the technology enablers that are coming from the other destinations should be demonstrated within this destination core. So that's why this is very important that there is a clear link and well-defined work program in order to make sure that this collaboration is successful and can be carried out. That's why if you are looking at the core text, there you can see that, for instance, in the destination 6, there are requirements for the other destinations defined. And also from the other destinations, we are asking to provide technology enablers to be demonstrated within destination 6. So, and another point is that at the end, this is also how we can make the regional network more efficient if we are thinking of the full system. So at the end of this, destination, we are also planning to have an integrated demonstration plan that is considering the different technologies and developments that are defined for this destination. So if we go now to the next slide, I would like to give you a brief overview, as my colleagues have done, on the demonstrations that are planned to be delivered by 2025. So as I said, that there are some different technical areas defined. So the demonstrators are listed based on that. So the first set of demonstrators are linked to the control, command, and signaling and operations aspect. And here you can see the following. The following demonstrate a single integrated operations control center covering interlocking, radio blocking, and traffic management for regional lines that are not functionally, operationally connected with main line. You can see after that the TRL level. Demonstrate simple on-track radio network based on the finding on destination 2 related with cost-efficient communication, supporting all FRMCS application, minimizing civil works and energy consumption to be achieved of cost-effective gigabyte train to use of public network coverage and compatibility with main lines. Then the next demonstrator that is linked to destination 1, demonstrate a specific application for traffic management systems for regional lines, improving resilience of a connected rail network, optimizing train operations, including disturbing events, taking into account high, low demand solutions, disturbance, and distraction. The next demonstration is linked to destination 2. So demonstrate a specific application for safe environment perception solutions, TRL 5, of FRMCS specifications V2X 5 giga TRL 5G, sorry, 5G TRL 5 for train positioning, 3RR5 for train integrity, for train length detection, and for digital platform for CCS validation and TSI verification and authorization for regional. So as I saw that also there was a question in the chat. So some of the technical enablers should be developed within destination 2, and then within destination 6. These are the demonstrations that would be expected. So here again, as I said earlier, so there is a strong collaboration will be required between these two demonstrations. If you go to the next slide, please, then we will see the other areas. So the asset demonstration here demonstrate a systematic approach with the implementation of different railway assets, in particular for cost-efficient, wireless, energy self-sufficient wayside components, in particular CCS trackside components. And then here you can see some examples, switches and level crossings for the infrastructure components, and if applicable for track vacancy detections and signaling shall be evaluated and demonstrated. It should be reached TRL 405. And then for the suitable customer services, demonstrate cost-efficient integration of onboard information of multimodal services, integrating regional multimodal services such as car sharing, and demonstrate passenger congestion rate monitoring, flow optimization application, as well as a low-cost passenger information system for regional services developed within this action. So these are the demonstrators that are expected within destination 6. And in addition, as I mentioned as well, here we are talking about a demonstration and also trying to focus on integrated demonstrators, so meaning that different components and solutions should be merged and carried out in a common demonstrator. So for this activity, also we are expecting preparatory works. So an important outcome of this destination is the preparatory work for integrated demonstrators within the duration of the program to showcase a high number of solutions developed and adapted for regional services can be deployed under an operational condition. In particular, taking into account the European dimension. So, of course, when we are talking about activities within the joint undertaking, we always have to bear in mind the European added value and then looking into solutions that can be deployed at European level. This is it from my side, and now I am available for questions together with all my other colleagues.
Thank you, Judith. So now we go back to the question and answer part. I think we are right on time. We have already replied quite intensively some question directly, so maybe I address those that were not yet answered. So I read them out. So one of the question of Odin is about if the automated shunting it's now fully transferred to FA2, and of course is referring to or destination 2 to what has been presented to destination 5. So I can briefly answer that. The destination, I will stop sharing. No, I can keep sharing. So the destination 5, as you can see, doesn't have a lot of automatic shunting, but it does have some initial activities. You can see in the multi-annual work program that further activities are foreseen in the second wave, but in the meantime, we need to have the technologies for this to happen. And so you have some automation technologies being developed as enabler before demonstrations could happen. in destination 2. So this is one of the input-output relation that you can see already in the text of the call, and you can further see the future relations of input-output, as Carl already replied in one of the chat question, in the annex of the multi-annual work program, where clearly all the relations are described. So I go on. So there is a question from Piero about the interoperability, if any, is foreseen achievable with passenger train and the standard coupling system of a passenger rail system, Scharfenberg type 10. In other words, will freight and passenger transport be split into two completely different domains or not? So actually, again, we're doing research and innovation activities. So I think the solution should be investigated by you, but it's clearly not our aim to have two completely different domains in a world where, of course, a lot of freight transport is run in a mixed situation. So in terms of if you are speaking about interoperability among passenger coaches and freight wagons, this was not part of our call text. So just to be clear, the call, I already replied, but the call is open to everyone. So the answer is yes, in the sense that it's open to all the eligible participant to Horizon Europe, according to the Horizon Europe rule. So this was mentioned at the very beginning, but it's important to highlight this part. I go on. I think this was not answered. Would the innovative device of mobile charging station for non-electrified capillary line be eligible for funding when it comes to test their application on heavy rails? So there have been already successful testing for tram trains. So I think we have some activities planned in the charging station. I don't know if Javier, you have the direct answer on this point, but so we have some activities planned for the, well, I don't know, Javier, if you already have, but in destination 4. Huh?
Yeah, I'm trying to check the question. I don't have it here. Join in a minute. Yeah.
So maybe while you are checking the question, then I go with the.
But I'll back to the question. I can reply in here also. So
exactly, reply there. But well, we have some activities. So usually everything is described, but we're, of course, if we can, we're going already to answer you right now. Then another question still from Olivier. The logic behind the mobile charging station. Ah, yes, it's linked to that. Okay. So I'll go on. Destination 6. Why considering the gigabit train requirement in the field of development of capillary, well, of a smaller line? So Judith, also there, if you can provide some additional information of this requirement.
Yeah, so there are two areas. So as I mentioned, so it's not only focusing on capillary lines, low density capillary lines, but it's also on regional lines, which can be high density. So that's why it, I would say that in this case, I would say that it's more related to those networks than for low density capillary lines.
Thank you, Judith. Another question from Massimiliano, which is the best way for a small enterprise to manifest its interest in participating to the call and get involved in the project proposal? Well, the best way you already started to do it, so participating to the info day, registering to it, and getting a knowledge of how to apply. As we already answer in some of those questions, we will distribute to the participants of this session who register each other contacts and especially the interest that they have manifested in terms of destination. So this will provide you already a first network in order of contacts in order to start to look into building up a project proposal. And you can of course also see on our website who are our members, and also you know that they will be contributing to the program itself, so you may also have already some relationship with them, and this could be another way of entering into contact for forming up a possible project proposal. Then Olivier is coming back still on the question on the mobile charging devices. So I let you reply once you have the answer, Javier. And then Stefan, could you please clarify the link between innovation pillar, flagship projects, destination? Yes, thank you, Stefan, because I actually realized that I should have mentioned at the very beginning this link. For us, you know, we are using this jargon language every day, so we tend to forget that, you know, participants are not so much used. So innovation pillar is the framework under which the research and innovation activities we are presenting today are structured. So it's just a structure for us to say a group it's under this innovation pillar. But each innovation pillar have a specific what we call flagship area. So areas of research and innovation activities that address a specific domain and that will result in a specific integrated demonstration. And those flagship area are implemented with flagship project. Okay, so you can see the logic, flagship project. We don't have one single flagship project for the entire description of the activities of the flagship area that is written in the multi-annual work program. But as I mentioned before, we will have 3 waves of them, at least from flagship area 1 to 6, 3 waves. So we will have 3 projects, 3 flagship projects. And the first set of flagship project, it's launched with this call. Okay, so with this call, we will have flagship project 1 that will be addressing the flagship area 1 of the innovation pillar. And the topic text, the name of the topic text could have been called flagship topic, but instead of being called a flagship topic, has been called destination. That's simply it. But you can think of the destination as the name of a flagship topic. Okay. Then could you please re-clarify the funding rate for research organization? So the funding rate, as explained by Carlo at the beginning, it's per action. So we have a total funding rate, action meaning project. Okay, so we have a total funding rate of 60% for. Sorry, I'm just having a problem with the chat. Chat is muted, so somebody muted the chat. Sorry, yeah. I will just go into the settings and unmute the chat, or maybe some colleagues can. Probably they can't because it's me. Allow meeting chat enabled. So I don't know why it's muted. So maybe somebody can look into that. But in general, yes, sorry, it's not muted anymore. So Carlo already replied with the funding rate. So it's again 60% on the eligible cost, and for the action itself. But within the consortium, each consortium can decide the funding rate of each of the organization in compliance with the rules of Horizon Europe, meaning that non-profit organization could claim up to 100% of the eligible cost. But this has to be rearranged inside the consortium to at the end up with a 60% overall. So how do you announce that you are interested in participating and in what area you can contribute? So you already did it, Answer. You already did it in registering to this meeting, because we have asked you to express the interest of the destination, and this one will be shared among the participants. If you think you have misplaced, you can write us in the chat right now, and then we will correct. But this is how we will show. In addition to that, don't forget that in the funding and tender portal of the European Commission, where actually our call for proposal is published, you have tools in order to find partners. So these are additional tools because everyone can express their interest also on our call through these tools of the Commission, which therefore are larger than just the participant to this meeting. And these tools are written in each topic text under the supporting document or supporting tool section. You can find a web link, and that explain to you how you can search for partners interested in this topic text. Okay, then Piero replied to Judith. Okay, we take into account your remark, Piero. Thank you. I don't think I have missed any presentation. So sorry, any question. So maybe I ask to Zanda and Eleni or other colleagues if I forgot a question. And Javier, you have to come back to the previous question, unless you already replied by chat.
I am replying on it just. I'm here with you. We are replying on it just now.
Okay, good. So you will have this reply.
Exactly.
Okay, Zanda, Eleni, I haven't forgot any questions. I think we have all replied. Yes, there is one last question. Private companies are having difficulty in acquiring data of infrastructure. Is there a way to overcome this problem? So we of course we are not us that will find the solution for this problem. I think it's quite important that you address this problem, but we have provided already possibly some means for you when we have described and when Carlo presented the expected composition of the consortium, that include also infrastructure manager. So we're expecting infrastructure manager to be part of the consortium that will submit a proposal to those destinations, and therefore those are the ones that own the data about the infrastructure, among others. And then, yes, sorry, another question, and then I will stop here so that we will give then the floor to my colleague. If we could explain the role of the deployment group and how it is linked to the two pillars. So the deployment group has not yet been formed. It will be formed shortly, but their role will really be to help the successful uptake of the innovation being developed in both the two pillars and the introduction of that into the market. So it's really about deployment and also probably also making the bridge to also future activities that are more deployment oriented. And also it's important to have this group because we need to have a common European deployment. You can see that all the systems that we're targeting are heavily dependent one from each other, And of course, their impact often it's only viable if implemented at large scale. So this is also why this deployment is essential, and the deployment group will also help us to achieve